Every AI coding agent you've used, Claude Code, Gemini CLI, Open Code, sends way more to the LLM than you think. Thousands of tokens of system prompt before it even reads a single line of your code. I got tired of that, so I tried something different. An open source coding agent built in Rust called ZAP. Let me show you what I have found. One line, no code, no Python, no Docker. ZAP is a single Rust binary under 30 megabytes. When idle, it sits at around 20 megabytes of RAM. Compared that to agents built on Node or Electron that needs an entire JavaScript runtime just to launch. That's it. That's the whole install. Now I've configured it with OpenCode as the provider using Go, Zen and GLM 5.2 as the model. Let me show you the stuff that actually matters. First thing, prompt load. Open any popular coding agent, type hi and inspect what it actually sends to the LLM. You will find hundreds, sometimes thousands of tokens of system prompt every single turn, no matter what you typed. I measure this myself and the ZAP team has the receipts. Gemini CLI sends the same 4096 tokens whether you're writing Java or React. The word Java doesn't even appear in its 68,000 character prompt file. OpenCode, same thing. One static prompt string, base anthropic code prompt, sent verbatim every single turn. Zero mentions of any specific language. ZAP does the opposite. Hey hi, and it costs about 30 tokens, not 2000, not 40,000 or 4,000, just 30. Second big thing, code indexing. Most agents read your code base by gripping for a string and hoping it's the right match. ZAP builds the real AST symbol index at startup. Tree sitter plus SQLite so the model actually knows what exists before it writes anything. That's a plain SQLite database at zap code.db. You can query it yourself, no ZAP session needed. Every function, every struct, every trait indexed with its exact file path and line number. Here's where it gets interesting. ZAP has this concept of context quality. Every token in the LLM context window has to earn its place. When you run /init, ZAP analyzes your repo and Bootstrap project knowledge writes in a zap.md with your project overview, build commands, architecture. It takes about 30 seconds. Then you run understand. And in one LLM call, it maps every business domain in your project to the files that owns it. Look at this, it wrote a full domain map. Agent runtime, tool execution, code intelligence, MCP integration all mapped to specific entry points and files. These files are never preloaded into context. The model reads them only when relevant. A session about fixing a typo doesn't pay the cost of loading your entire project architecture. That's what I meant by context quality. You only pay for what you use. ZAP ships with built-in skills for Rust, Python, TypeScript, React, Go, Git, debugging, security, code review, all compiled into the binary zero config. But the real power is custom skills. I can create a project-specific skill in seconds. Here I am creating an API convention skill. It's just a markdown file with a trigger list. A few more things that surprised me. Token cost display. Every turn shows exactly what went into the context. skills, messages, system prompt, and estimated dollar cost. Full transparency. Actual turn detection. Say, thanks, looks good, and ZAP knows it's not a coding question. The prompt drops to about 31 tokens. Other agents still send their full 4000 token system prompt for a thanks. You can always view the index quality output and you get a health score for your code base. File sizes, God objects, dead code candidates, all powered by the same SQLite index, no extra tools needed. That's ZAP, a single rest binary, AST powered indexing skills that only fire when needed, and a context system that doesn't waste a single token. It's fully open source, MIT license. I have dropped the GitHub link in the description. Go try it, break it, tell them what you think. If this was useful, drop a like. I'll see you in the next one.